Let's dust off those graphing cobwebs. Pause the video while you write these two questions and answer them in your composition book. Now let's see how well you did. Here's the formula for slope, and if you calculated the slope of the green line to be 0.75, you would be correct. Now let's get serious about graphing motion. We will start by looking at position time graphs. Let's start with this. What does this graph show? Well, this graph shows the position of an object over a period of time. And what does the slope of a position time graph represent? Well, let's examine this by looking at the slope formula. We know that slope is delta y over delta x. And on this particular graph, y is represented by centimeters and x is represented by seconds. This means that the slope is centimeters over seconds. This can also be represented as displacement over time. And we know that displacement over time is velocity. Therefore, the slope of a position time graph represents the velocity of the object. Now let's examine this graph. When is this object moving at a constant speed? You should have this graph in your baggie. Find it and let's write some things on it before we glue it in. Remember that the slope is going to tell me the velocity. So if I have a constant speed, that means I have a constant slope. So on this graph, that would be the section from 0 to 6 seconds. Now let's figure out when the object is accelerating. If it's accelerating, then the velocity is changing, which would mean the slope is changing. So the section from 11 to 18 seconds is when the object is accelerating. So when is the object stationary? If it's stationary, then there is no velocity. Therefore, the line would be horizontal, so from 6 to 11 seconds. Now you can glue this graph in your composition book. Now let's find the speed of the object during the first 6 seconds. Remember that the slope is going to tell me the velocity. So I need to look at the slope, delta y over delta x. Now plug in your values for change in y and change in x, and you should get a slope of 1.7 meters per second. Let's look at this position time graph that has several different lines on it. Find it in your baggie and glue it in your composition book. Which of these represents the object moving in the positive direction with constant speed? Well, remember on a position time graph that the slope is going to tell me the speed and the direction. So if it's moving in the positive direction with constant speed, then I need a line that has a constant slope that is positive, and on this graph that would be line B. Which line represents the object moving in the positive direction at a slow constant speed, then faster at a constant speed? That would be the line with a small positive slope that then turns to a larger positive slope. So line E. So how about moving in the negative direction and speeding up? So now I want one with a negative slope that's getting steeper. So that would be line CF. Now which one is at rest? Hopefully that's pretty easy for you to know that that would be line A. Alrighty, how about moving in the positive direction and slowing down? That means it has a positive slope that's getting smaller, so that would be line D. And lastly, moving with a negative velocity and a negative acceleration. Well, you only have one left, and that would be line G, but let's examine why. Negative velocity would mean that the slope is negative, and negative acceleration would mean that that slope is getting smaller. Therefore, G is the only one that fits. And now for something completely different, velocity time graphs. Find this graph in your baggie and let's write some things on it before we glue it down. What does a velocity time graph represent? Well, it shows the velocity of an object over a period of time. When is the object moving at a constant speed? Since this is a velocity time graph, that means I'm looking at when the graph is constant or when the slope is not changing. So when is the object stationary? Well, when the velocity is 0, so during the first 3 seconds. When is this object's speed increasing? Well, that would be from 3 to 6 seconds. And what do we call it when something is increasing speed? That would be acceleration, positively accelerating. When is the object's speed decreasing? Well, that would be from 8 to 10 seconds. And what is this called? Well, that would be negatively accelerating. So looking at this, what does that tell you about the slope? Well, hopefully you figured out that slope is acceleration on a velocity time graph. Now glue this in your composition book. Let's examine this set of velocity time graphs. Find these in your baggie and glue them in your composition book. Notice the placement of 0 and the fact that we have some positive velocities and some negative velocities. First, which one is moving in the positive direction at constant speed? Remember, this is a velocity time graph, so we're not looking at the slope, we're just looking at the velocity. Line B is the only one that represents a constant speed. Which one is moving with a positive velocity and a positive acceleration? Since this is a velocity time graph, acceleration is the slope of the line. So the line with the positive slope would be line E. Which one is at rest? The one with no velocity is the one that's at rest. That would be line A. How about moving with a positive velocity and a negative acceleration? Positive velocity would mean that the line is above zero, and negative acceleration means it has a negative slope, so that would be line F. Lastly, moving with a positive velocity at constant speed, then decelerating to a rest position. Constant velocity would be a horizontal line, and then decelerating would mean that the velocity is decreasing until rest position, which would be zero, so line G. Find this graph, it should be the last one you have, and find the area of the green rectangle. Well, area is length times width, so let's figure out what those things are for this rectangle. The width is 10 meters per second, and the length is 10 seconds. So let's put those in the area equation, length times width, and you get an area of 100 meters. This tells us that on a velocity time graph, area gives me the distance traveled.